with Kotlin? Oh, not really much, so it's really good, so I can speak whatever I want. Actually, I'll ask a lot of questions. You can answer them and win some prizes. Let me introduce myself. My name is Marharyta. I work as software engineer at Wix. I'm also a Kotlin adopter, and I like Kotlin very much. So I organize different conferences, meetups, and I'm also in Devoxx UA program community member. So you can contact me whenever topic you want, and you can follow me on Twitter and else. One more thing, it's a really important thing about me that you should know. I really enjoy boxing, so think twice before asking some tricky questions. Of course, I'm kidding. So today we'll talk about a few words about laziness, because our talk is about lazy. Why is it important and why should we use it? Then about Kotlin and laziness, how we can combine this. And then like lazy initialization, lazy operations with collections, how we can be lazy with coroutines, and a short demo. One more thing, do not forget to tweet with these hashtags, because at the end of our session, we'll define winners, those whose tweets got the most likes, and he'll also get these prizes, he or she. And be active and receive prizes. I'll ask some questions, and you can answer them. Before we start, let me introduce this guy. I hope everyone knows him. He is the most lazy guy I can imagine, and he'll help us today to be lazy. So first of all, laziness. Is it good or not? When I was a young girl, my mother always told me that being lazy is not okay. You should be hardworking, you should learn, you should work in order to achieve something. And I was really hardworking and tried to be the best student in school, in university. But at some point, I found out a quote of Bill Gates, and he told me, not me, but us, I'd rather choose a lazy person to do a hard job because a lazy person will find an easiest way to do it. And I started to think, maybe it's not really bad being lazy. Maybe being lazy, it's okay. Maybe lazy people can also achieve some achievements. And of course, yes, laziness can help us in our life. You just don't do things which you don't need, and you save your money, your time, and your life, and you enjoy your life. But laziness can not only help in your life, but it can help in our work. There is a term called lazy evaluations. It's an evaluation strategy which delays the evaluation until we need this expression's value. It's pretty nice, because if we don't need something, why should we evaluate it? So we talked a little about why should we use laziness. I guess it's more or less clear. So let's talk about Kotlin. Actually, Kotlin loves lazy people. It loves us very much. First of all, because we write pretty less code. You can see that on the left side it's Java, and on the right side the same stuff in Kotlin. Which one would you prefer? Yeah. So as for me, I like the second one with Kotlin, and I guess you too, because I'm lazy, I don't want to write much code, and Kotlin works okay for me. But it's not only about the amount of code. In Kotlin, you also can use lazy evaluations, and because of this, you can make your programs work efficiently. You use less memory, less money of your company, and the less your company pays to Amazon or Google, the more it pays for you, and for me, it's okay. So let's start. First of all, let's talk about lazy initialization, because it's always starts from variables. When you're programming, you use a lot of variables, and you need to initialize them somehow. So let's start from Java, how we did it in Java, and then we'll compare it how we do it in Kotlin. First of all, let's imagine we have some lazy class, we have some lazy field, and we have some calc lazy field, really complicated logic. It's important to understand that logic is complicated because you need to be lazy only when this logic is really hard, complicated, and it's time-consuming and memory-consuming. Why is it so? Because if your logic is simple, sometimes it's really better just to do it than to postpone it. So let's think about it and never return to this point. So, in this class, we just have getter, get lazy field, and we check if this lazy field was already initialized, we just initialize it. We don't initialize it. And if it wasn't, we just call lazy field. So, sounds pretty good, pretty simple, and I hope no one really wrote this code anytime. So let's do like baby steps in Kotlin. We just started learning it. We never had an idea how to do this in Kotlin, and we tried to do the same stuff in Kotlin. So we have the same lazy class, we have the same lazy field, and have the same private function calc lazy field. How can we do this? We do the same stuff, we're just implementing getter. In Kotlin, we should do it this way. It's not really pretty. So you can see that because of Kotlin limitations, we need to introduce one more private field, which is nullable. And please raise your hand if you like this code. No one of you like this code, and me too. I also don't like it. And if someone told me that it is the only way to do lazy initialization in Kotlin, I will forget about Kotlin and turn to Java. But let's be more smart and understand that in Kotlin we have more stuff. In Kotlin we can do lazy initialization using delegates. How can we do this? We have the same lazy class, the same lazy field, and the same calc lazy logic. And while we are initializing lazy field, we are just using keyword by and saying the compilers that now I won't initialize it by myself, I want lazy initializer to do it, and that's all. This is the code you need to write to make your lazy initialization. Is there something that you're disappointed with? I guess you might be disappointed with this lazy initializer, because there is a question, where is it, how it works, and who wrote it? It's not a secret. I wrote this lazy initializer, and here it is. It's not really pretty. It looks like the same code we wrote before, but it is hidden in lazy initializer. So you write this code once, and you can use it everywhere. The main disadvantage of this code is that you need to write it somewhere. And it's not really pretty because we still have to deal with getter, and we have to deal with this private field. But maybe someone can tell me in which situation this code won't work. Be active. You can raise your hand. Yeah?
It's not thread safe.
Yes, of course. So it's your presence. Yeah. This implementation is not really thread safe. So if you have more than one thread, it will fail and it won't be lazy. But there is a solution for this. In Kotlin, guys who developed the language already thought about it, and they created their own lazy delegates on their own. So you just use that lazy, and that's all. So if you want to be lazy field initialized lazily, you just use lazy. And out of the box, you get thread safe, because this lazy function is thread safe. But you also can make it not thread safe if you need it. So that's all about laziness. But in addition, we also can do this not only with properties, we can use it in initializing of local variables. For example, let's consider we have these 3 lines of code. In first line, we just have value a, which is 1 divided by 0. By the way, if you have this code, what we'll receive? Which exception? No. Which type of exception? Oh. Okay, it's arithmetic exception. Yeah. And then we here have this second line that tells us if true, return 1, else return A. And then we print B. So when we run this program, we receive arithmetic exception. But if we look at the second line, we understand that we really don't ever use branch else. In any time, we'll just return 1. And maybe we don't need to calculate A. But because we just need to calculate it before, we have this exception. But we can do this in lazy way. We are just saying that value A would be evaluated by lazy. And when we just run the first line of code, it won't be evaluated at all, because it will be postponed until we need it. In the second line, we return 1, and we never calculate value of A, and everything is OK. So it's just almost the same code, but the second one will work OK, and the first one will throw an arithmetic exception. So you can tell me which is the use case of this, because it's a really cool feature, but I'm not sure that we can use it. The most common use case is logging, because sometimes when you try to log something, you need to do some complicated evaluations of the strings that you want to log. And if your debugging level is not debug, maybe you don't really need it. But if you don't do this lazy, you'll evaluate these messages anytime, anywhere. So we can do it using this by lazy. And if you do this, your message won't be evaluated unless your login level is debug. So you can use it in this case or in any other case. Sometimes you don't really initialize your variables on your own. Sometimes some framework does it. For example, raise your hands, those of you who are using Spring. Most of you are using Spring. When in our company we use Spring. So let's again remember how we do it in Java. In Java we have some component and we outwire some field. So most of you have written this code, and me too. So let's do the same stuff in Kotlin. In Kotlin, we have some class, we have some service, we can do almost the same stuff. So please tell me, will this code work or not? Actually, those of you who are familiar. No, and why?
Because it's not initialized.
Yeah, it's because it's not initialized, and maybe you can tell which problems we have here.
Well, it's null, and I think Kotlin needs to...
Yeah, it's exactly the right question. We have the right answer. We have like two problems. First of all, we told that some service is well, but it can't be well because some framework will inject it, and its value will be changed, and it should be var. And the second one, we told our compiler that some service is non-nullable. So we cannot pass there null. In Java, before for Spring initialize some service, there would be null, and after that, some value. In Kotlin, we can't pull the null. We just need to create some value for this. So the first obvious solution, let's use nullable type. So in this way, if you just tell one time to compilers that your some service is nullable, you have to deal with question marks everywhere. Because if you tell that some service is nullable, you need to all the time put question marks, because your some service is nullable and it's not safely. And actually, it's not really good solution, because I want to work Kotlin to have less boilerplate, but by doing this, we'll have even more boilerplate. But there is a solution. We can just tell that Lateinit var, and Lateinit is just keyword that tells a compiler that var some service is non-nullable, and at some point in our program, it will be initialized. If you try to use it without, and it was not initialized, you'll get some exception. But a few months ago, I was on talk of Josh Long, and he told us that we should not really do property injection, because when we do property injection, somewhere dies one unit test. So let's use the constructor-based injection, and Josh Long is happy. But it's about Spring, but any other framework, you just need to use Lateinit. Let's look at more examples about Lateinit, how it works, what features do we have, and maybe we have some more analogs of Lateinit, maybe we have some more stuff. First of all, Lateinit is a really interesting feature because we can check if variable was really initialized by using this strange constructor. And this construction works only from Kotlin version 1.2. So using this construction, you can check if late field was already initialized or not. And based on this, you can build your own logic. And there is also one more option. You can use delegates not null. Lateinit is a keyword built in language, and delegates not null is custom delegate, which was built with instruments of Kotlin. And unfortunately, using this delegate, you cannot check if variable was initialized or not. You can ask me, why don't you use just null check and check if it's null, and then just initialize. So let's do this way. And we can do this but compiler looks at this code and thinks that we are a little crazy and stupid. Why is it so? Because we told that late field is int, it's not nullable, and we're checking that it's null. Kotlin thinks that it's not nullable, it will never be null. So because of this, there are also some puzzles and some problems in Kotlin, but late field equals null will be turned to this code by compiler. It'll just be false, and will never really execute this code. So you can pull yourself in a lag. That's why there is no really way to check if late field was initialized. Let's now summarize Lateinit versus delegates not null, maybe what to use in which situation. First of all, Lateinit is cheap. Why is it cheap? Because it's natively supported, it's built in language, it's keyword. Then we can inject directly to JVM field. So it works perfectly with frameworks. Lateinit allows to check out if it was initialized, but from version of Kotlin 1.2. But we can't use Lateinit with primitives. And delegates not null. This creates one extra object per property because it's delegate. Delegate was built with Kotlin, and it's not really good. Then you cannot inject directly to JVM field. You cannot check if it was initialized, but there is one cool feature. You can use it with primitives. So for int, long, double, it's the best way, the only way, I guess. So we are finished with lazy initialization, but we are doing not only with variables, we are working a lot with collections. I guess most of you are working with collections. Let's look into lazy operations with collections. In Java, we used to do this code. I guess before Java 8, it was not really funny stuff to work with collection, but with Java 8, we have awesome streams. We can do some filter map, flat map, and all the stuff in one stream, and it looks pretty. But there was one, not a problem, but one thing that we wanted to improve. Why we always need this stream? Why don't just do some stuff from collection? Because it's like strange stuff. We just always need to call stream, and after that some filter, map, flat map, and those. In Kotlin, they said that we can do the same stuff just with collections. Let's do it. So we can have the same collection, and we can call filter, map, flat map, and other stuff directly from collection. And it rocks. It's really cool. But suddenly, at some point, your manager comes to you and tells you that you switched to Kotlin, you are not using streams, and now we are having a lot of memory leaks, we have a lot of problems, and we pay much money to Amazon, and we need to fire you because we have no money. So why is it so? When you're using these all methods directly from collections, you're having this way. In our example, we had a list of the strings, and we wanted to filter out those strings that do not contain A. So we create the second list, which not contains elements without A. So we have one more list. Then we did map, and we created one more list. And after that, we just get the first element. The thing is, for list of 6 elements, we already created 2 additional lists of 5 elements. It doesn't matter if your collection contains of 6 or 10 elements, but it matters when your collection is of 5 million elements, 5 billion elements, and it really matters. And your computations would be long, it would be memory consuming. So maybe there is a way to somehow deal with it and to make your collections lazy. Yeah, first of all, you can use Java 8 stream. You can return to old funny streams because they worked lazily. And now you just, by adding one more line of code and telling the stream, you can see how it works. We take the first element, we see that it doesn't match our predicate, and we return. We get the second one. The second one element, it contains letter A, thus it sweets us, and then we make map, and after that we just return it. So it's much easier, much simpler, and in this way we save your time, your money, and it's more efficient, and everyone is happy, and your manager is happy, and he won't fire you. But what if I want to reuse existing stream? So I have stream, I made some calculations, I returned some values, and I want to reuse this stream one more time. For example, like this way. Who can tell me what will be returned? Yeah, and what exception? Actually, it's more general exception. Unfortunately, it's not really concrete. I have one more duck. Duck is designed by Wix. Okay, who was the first who told that we will receive an exception? Okay, who wants duck? Okay, so yeah, we'll receive a legal state exception because your stream was already processed and we cannot reuse it, unfortunately. Yeah. So now, if you want to reuse your collection with stream, you need to deal with this situation. And now it looks more like a punishment than like a feature because you always need to type stream, 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 and it's not really good. Is there any solution? And yes, it is. Kotlin provides us with sequences. Sequence is analog of stream, but with some features. So if we write in sequence like this way, we can use it as many times as you want because they are reusable, and this code will work. Let's compare sequence versus streams and understand when to use which. When to use what? First of all, streams cannot be reusable. Then streams have poor API because they are from Java, and in Java they don't really think about programmers, and you need to write most methods on your own. You just can use existing method and pass some strange lambdas. In streams there is method pick. By the way, who knows what this method does? Yeah? Yeah, it takes, and you can use it during login, so it's your duck. Yeah. I'm not really sure that a lot of people really used it, but it's a cool feature. There are streams for primitives, for example, int streams, double streams, long streams, and it's really cool because you can have like maximum, average, sum, and it's pretty simple and makes less boilerplate. And streams can be parallel. You just can use parallel streams and do your stuff like in many threads. But for streams, you need Java 8. I hope no one really uses less than Java 8. But sequences. Sequences can be reusable. We already talked about it. Sequences have rich API because they are developed in Kotlin, and we have a lot of different methods. For example, we don't only have filter, we have filter node, we have some stuff. We can have that all elements are okay with some predicate, and it's really cool because you write less code. But unfortunately, sequences doesn't have method pick. I know it's really a huge disadvantage. But from version 1.1, they have method on each, which does the same stuff as pick. So now it's not only really disadvantage. But unfortunately, sequences have not primitive variants. So it's like only sequence, and you can only use generics. It's because in Kotlin you don't really deal with primitives. And sequences are not parallel. I think that they are working on it, but now they're not. And sequences can be infinite. Let's talk a little about infinite sequences. It's really cool stuff because of infinite sequences, we can really use some reactive streams, and we can do streaming. So let's look at a simple example. We can generate infinite stream of natural numbers just by doing this. So we can pass lambda and print first two elements. So you can see that generate sequence, it doesn't really generate any number. In generate sequence, we just say that we'll have this sequence of infinite sequence, but numbers will be generated only with method take. We can also pass some seed to generate sequence and do some crazy stuff. For example, we can generate Fibonacci sequence using generate sequence. How can we do this? As you know, when you pass seed, you can use previous element to generate a new one. But for Fibonacci sequence, it's not enough to use one previous element because we need two previous elements. So we just have a pair of elements, and we generate a pair of Fibonacci sequence. So the logic is simple. We have the second element and the sum of the first and second. And after that, as far as we do not need really pairs of Fibonacci sequence, we need only elements. We just do map and take only first elements. And after that, we deal with it like the simple sequence. We can take some elements and do some stuff with it. So the most interesting part is being lazy with coroutines. To be lazy with coroutines, you can use two methods. It's build sequence and build iterator. Build sequence does almost the same stuff as generate sequence, but it uses coroutine, and we can just now look how it works and why do we need this. Sometimes it's not enough only just to have previous element, like we did with generate sequence. We need to share state between call of your method. For example, let's generate sequence of all primes. To generate this sequence, we'll just accumulate all previous primes and then check that your new candidate is divided by any of that primes. If it's true, it's not prime, and we'll switch to next candidate. If it doesn't divide to any of the primes, it's prime, and we add it. So, list of primes is shared state. In order not to put this on a high level, in order to somehow conceal it, we use this build sequence, and now this mutable list of primes is concealed in this build sequence and is shared only between calls of the function, only here. So for doing this, we are using build sequence method, which is coroutine builder, and now you created a coroutine. And in order to return value, you use method yield. What does method yield? It returns value which you passed, it's candidate, and it saves the context of evaluation. So next time, when you take one more element, you proceed with this place. So you do primes add and go to the next iteration. So you see that it's infinite loop, but it works okay because it works lazily. So you just need to understand that build sequence and method yield, they just work together. Build sequence create coroutine, and yield just returns elements and saves the context. So I didn't show you some kind of work with build iterator because I'll show you it in demo. First of all, some words about demo. I implemented some tree to say in which I save my words. So it's a dictionary, prefix dictionary. I do not save my strings like strings. I just put chars. And in order to find one word, you need to go through this tree and accumulate all chars. So you can see that the word bird is like this line. You just have B-E-A-R-D. So it's pretty simple because it needs less memory, and you can do some search quicker. So it's construction called prefix tree, and you can use it, and it's actually used for some computations with strings. So how it works now? For example, I want to have some two first words with, which starts from letter B. First of all, I have letter B, then I have letter B, B, A, B, 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 E, and then I found two words, bad and bad, and I record them. But after that, I found more words and more words. So I found all words that I saved in my tree, and after that, I took the second two. But as you can understand, only on the third step, I already found what I needed. So I don't really need these two steps. But unfortunately, my program doesn't work lazily. That's why I do this stuff. So the task is to refactor this, the code that doesn't work lazily, to be lazy. How can we do this? First of all, let's just run. Let's run, and we'll see that we'll got, so we returned first 5 letters as we want to take, but actually we found all words that are in my dictionary, which is not really good. So let's refactor it to be lazy. How can we do this? We go to that tree. Is everything clear, or I need to scale my, to do this stuff? Is it okay? So first of all, what we'll see, we'll use build iterator. So now we'll return collection with lazy iterator. So we're using this build iterator stuff. And now we need to use yield in order to return some values. So before this, we just accumulated this in some collection. And now we don't need that collection. You're just doing yield. And now we need to fix like the functions that called us. It should return some iterable. And in this is iterable, we just put our build iterator. So we create like custom collection with iterator that we pass there. So let's check how it works now. And how it works. So now you can see that we find pretty less words. So it works lazily now. Let's return to our presentation and see how it works now. Now we just find the first letter, word, then we found the second word, and that's enough. Because we asked only 2 first words, and we don't really need to calculate every word that we have in our dictionary. And now we just, you can see that we changed 3 lines of code, and now it works lazily. So if you want to play with this demo, you also have this QR code, but I'll share my presentation, so you don't really need to scan this code. Final puzzle, it's for a dog or for any present you want. I have built this collection, and I did some filter. And I want to take first 5 elements, which length is more than 5. Please raise your hands, those of you who are thinking that the answer is A. Don't be shy. Are you still thinking, or you don't want to vote for letter A? We don't have much time, so let's start voting. It would be funny. So letter A, who is voting for letter A? Okay, who is voting for letter B? Okay, who is voting for letter C? And who is voting for letter D? Yeah, and now answer. And finally, answer is on my computer. It did 60,142 iterations, and then it crashed. So the question, why is it so? Yeah? Yeah, actually, because filter is not lazy. Because we are working on collection. We do not work with lazy stream or sequence. We are working with iterable, which is so it's not lazy, and this is your dog. Oh, I'm sorry. I need to practice more. So let's summarize. Laziness benefits. First of all, you ain't gonna need it principle. So you don't need what you don't do things that you don't need. Then you can somehow define flow control. We did it with like lazy of control flow. Then you can work with potentially infinite data structures, which is really cool because you can do streaming, and it's important. There are some drawbacks of laziness. First of all, it produces overhead. Because if you just wrote code as it was, and then you just decided to be lazy, you always do some additional stuff, and it would be overhead. Then sometimes there won't be performance benefits, because Because sometimes maybe the overhead that you produced it takes much time than the benefit you expected. And sometimes you can have unexpected behavior, for example, as we saw in puzzle, because you need to see documentation to read more about how it works. And if you work with frameworks, sometimes you also don't really know how it works, and you need to dig and to look into documentation. So a simple takeaways I want you to take from my presentation. First of all, laziness can improve your performance. Laziness brings overhead, so be lazy only when you need it. If you need it, Kotlin can help you, because my talk was really about Kotlin, so I need to mention it somehow. And read documentation, look for hidden gems, and solve puzzles. It's time to define winners. In the beginning of our session, I asked you to tweet. I hope someone tweeted, because yeah, I need to. My connection is not really cool. So we'll proceed with it. Let's go to, if you have some questions, you can ask me.
Why filter is not lazy?
What?
Why filter is not lazy?
It's not actually about the filter. It means that filter doesn't want to stop because iterable that you created is not lazy. It's collection. When you use, when I gave you examples, I used method take. Method take works lazily. But method filter, it works like iterable is collection. So it works like on a list, on array list, and it doesn't work like on stream or sequence. That's what the problem. Because you need to, I actually don't know why they designed it so. It's the same. It's like filter that is in a stream and in Java. So it's Java filter. It's not Kotlin filter. Yeah, it's just it's just how Kotlin collection works with it, and it's infinite data structure, so works with it. So maybe we should think. Yeah. Unfortunately, no one really tweeted. So we have only my 2 tweets about Kotlin and Vox Days. So it's my prizes. So maybe I have more questions. By the way, good question. So for you, I have a lot of prizes. Yeah, I have a lot of prizes, so I really don't want to take them home. And I want you to ask questions in order to receive them. By the way, I have also stickers from my company. If you want, you can take them. They're here. So thank you for coming. Thank you for your attention. And that's all.